Hi, I'm Thomas and this is Pilot's Workshop. After putting the wheel mechanics on the leg assembly in the last episode, there's no need to turn the workbench upside down anymore. So the weight does no longer matter and we can unite the two halves of the workbench. As some of you may have noticed already, the top frame and legs won't be joined with typical woodworking methods. Instead, we have a bolted connection that follows the engineering principle of the division of tasks, which simply means that different forces acting on a construction are absorbed by different elements of it. The top frame rests on the narrow shoulder on two sides of each leg beam, which takes in vertical forces. Horizontal forces are accepted by the vertical surfaces. To keep the legs from twisting under pressure, each of those surfaces is being pulled towards the top frame with heavy bolts, with every twisting moment being absorbed by the large dovetails in the corners and on the support beams in the middle. The reason I chose this type of connection over, for example, a mortise and tenon joint at this spot is longevity. As a workbench is being used, being pushed back and forth when planing a board or chiseling a joint, it has to withstand a swaying horizontal motion. That way the wood around the contact points of each joint gets compressed a bit, which over time results in a loose joint. As our workbench is made from softwood, this effect would appear even faster than with hardwood like oak, maple or beech. On top of that go the enormous vibrations from the router that will be embedded in the work surface that would just eat up a regular joint. With that router being used, the workbench goes through vibrations that a regular one would see in decades in a matter of days. The bolts are supposed to counter that effect by pressing the opposing pieces onto each other, this way introducing a pressure to the surfaces from the start, which even out the effect of that swaying motion and vibration, like in a very tight and new mortise and tenon joint. The big advantage, however, is the ability to retighten the connection at any point by the turn of a nut. But that's enough talking. Let's begin. Before putting the pieces together, I checked the dimensions of the leg assembly and top frame. While the leg assembly was within a millimeter in both directions, the top frame was about 4 millimeters short, so it wouldn't have fit on the leg assembly. The easy solution was to cut off a slice of 4 millimeters on both beams on one side of the workbench. I chose the side where the vise and router would be to give it a larger contact surface with the frame, as it is the side that will see the most stress. So I marked the required measurement and drew a line on all three sides. Then followed a careful procedure with a handsaw. I took my time here to keep the saw cut straight. In case my error would have been the other way around and the leg assembly would have been too short, aka the frame too long, I would have filled the resulting gap with a sheet of thin plywood. A difference of less than 2 millimeters between frame and legs in any direction would have been okay in my book and not require any adjusting. After the slice has been cut off, the cutting surface can be cleaned up with a chisel. It doesn't need to look perfect, but should be overall straight and flat. I checked this with the side of a chisel as I went along. The final touch is a small chamfer on the top edge of the contact surfaces, making the mounting of the top frame easier. Then the fresh surface receives some linseed oil. Now comes the big moment. At this point, both the leg assembly and the top frame have a weight that I could still handle by myself, even though I should advise to do this with a partner. Thanks to the chamfers, it should slide on quite well. When it's well seated and the leg beams sit in the corners nicely, the bolts can be put in. I first drilled small countersinks, just deep enough for the screw heads to clear the surface. Again, I am using carriage bolts for the ability to tighten the joint with one hand, because some of the screw heads won't be accessible anymore once the workbench is finished. Next, the holes could be drilled through and the bolts inserted. In the past episode I now squared up the first few millimeters of each hole to take in the square of the bolt. But because the spruce of the frame is quite soft, they can be hammered in straight away. I then took the largest washers I could find and screwed on the nuts. Finally, the nuts have to be tightened carefully, each a bit at a time, one after the other, to let the beam settle tightly in the corner of the frame. After a few rotations, the force required to keep turning stays the same. That's the point at which to stop, as from now on the screw will simply sink deeper into the wood. And that's already it for this episode. In the next one we're going to mount the Twin-Screw Vise. So see you in the next video. This is Pilot's Workshop. Thank you for watching.